Hello everyone, welcome to today's lecture on types of databases used in data mining. So, in our previous lecture, we discussed the basics of data mining and understood how it helps to discover useful knowledge from large data sets. Before applying any data mining technique, we must understand where the data comes from. And data can be stored in many different types of databases, and each database stores information in a unique way. So in today's session we will learn about the major types of databases that are commonly used in data mining and understand their real world application. So the first database which we are going to discuss is the basic database, which is nothing but the traditional one or transactional database. So wherever any transaction, for example in banking, that happens, the database which we use is transactional database, for example. So let's begin with the most common type of database, transactional databases. So basically a transactional database stores records of all daily business transactions. Each transaction contains a unique transaction ID which differs from person to person, user to user. So if I have a particular transaction number, for example say T100 in this example, this will not be repeated again, but the list of items, nothing but the item IDs I1, I3, I8, I16, that could be repeated. For example, I am going to a grocery shop and I am purchasing a list of 4 of items. So say I1, I3, I2, I8, I16, those are the list of items. So this list of items can be repeated, but my transaction ID or number which will not be repeated. So this way we will be able to track down the transaction. So each transaction contains a unique transaction ID and the list of items involved in the transaction. So once again I'm telling, the transaction ID will not be repeated, but the list of items will be repeated in the transaction. For example, when a customer purchases a laptop, mouse and printer from an online store, all these purchased items are stored together as one transaction. Now why is this useful? Let me say, suppose thousands of customers purchase computer and printers together. So data mining can discover this hidden pattern. So how many people they are purchasing computers and what type of computers and from which brand and also which year. So we will be able to find out this pattern. So if they buy a particular product, what could be the product they can purchase along with that. That is the basic pattern and hidden pattern. So this analysis is known as the market basket analysis. So basically we will say as MBA. So businesses uses these patterns to recommend products, arrange shelves in supermarkets and create attractive product bundles so that people they used to buy their products. So whenever you see Amazon recommending frequently bought together, that recommendation is generated using transactional data. For example, and another example, let me say, if a particular user is buying a mobile phone, when you scroll down you will be able to see you can also buy together, for example a headset or temper glass, etc. So people will prone to buy that item also. So these are all basically the frequently bought together. So now I ask you one question: can you think of another online shopping website that recommends related products? So you can think of. So moving on to next, object relational databases. So basically what is an object? So let me say, if I take a mobile phone, it is an object, but each and every object will have some attributes. If for example for the same mobile phone, the attributes would be size of pixel, its resolution, then the weight of the mobile, then the storage capacity of mobile phone. So all this you can take it as an example. Let me say another example. For example, take car. The attributes of car, that would be how many tires, what type of engine it has, what is the color of the car, from which brand, all this about attributes. So object basically it contains a list of features along with the attributes. So, traditional relational databases mainly store rows and columns, but however, modern applications often need to store complex objects such as images, videos, customer profiles, or engineering design. So, to overcome the transactional database, we introduce object relational database, because in transaction we will be able to store your products or any transaction in terms of rows and columns. But when I want to go for other type of data such as images and videos, we can use this object relational databases. So I have the object and also relational, basically that depicts a relationship between one object to one another object. So this is what basically object relational database. For this purpose we use object relational databases. Here every object contains both data and methods. So what is the, what is data? And now let me say what is the method. Basically a method is nothing but the function. So whenever you call a function, you use a method, you will be able to execute some logic part out of it, and you will be able to get some output from that. So the logical part basically we represent in methods. So for example, consider an employee object. So instead of storing only one employee details, the object can also contain methods like calculating salary or updating employee information. So here the object is the employee, and the details are nothing but calculating their salary, updating employee. To do all that we need the methods. So basically objects have similar characteristics which are grouped into classes. So classes are nothing but it's a blueprint, and whenever you call any methods or function, you will not be able to call without any object. So you have to create an object under the classes, then we will be able to call any function. So this is a simple example you can relate with a Python programming language. So this approach combines the advantages of relational databases with object oriented programming. So it is widely used in enterprise applications where complex data structures need to be managed efficiently. And here also you can see a set of variables that basically describes the objects, and set of messages where the object can use to communicate with other objects, and also a set of methods where your logical path or method holds the code to implement a particular message. So next, temporal databases, sequence databases, and time series databases. So there are three important databases which you can relate with the time. So all these three types relates with only the time. So the first one is temporal databases. It stores data along with the time information. For example, employee salary history or patient medical records over several years. So if you take a particular company, they will be storing the history of the salary of all the employees over the period of time. And also if you take an hospital, medical record of all the patients also will be stored. So the next one is the sequence database. Here the order of events is important. So what kind of order you are going to execute, that matters. For example, a customer's shopping history may look like this. First they buy a mobile phone, later they purchase a phone, then they buy a smartwatch. So all these are related with electrical items. So this is nothing but the pattern or sequence where they buy over the period of time. So the sequence itself contains valuable information. Finally we have the third one, time series database. So these store measurements collected continuously over the time. Example includes in stock market traces. For example, morning they will open the stock and evening they will close the stock. So it will differ the product to product and time to time. And also by the temperature, if you take a particular day, that will also differ. And electricity consumption differ from hour to hour or day to day, etc. And also the heart rate monitoring. So these are the examples which you can take it as an example for time series database. So time series databases are widely used for forecasting the future values, to predict the future values. Now I am going to ask you another question. Can you identify any mobile application that continuously records time based data? So think and answer. Next, spatial databases and spatio-temporal database. So another important category deals with the location basically. So when I relate the temporal databases, it relates with the time. So whenever I speak about the spatial, it relates with the location. But what about spatio-temporal? It relates with the space as well as the time. So now let me explain about the spatial database. Spatial databases store geographical information of any area. Example that includes maps, satellite images, road networks, and GPS locations. So applications such as Google Maps and vehicle navigation systems depends on the spatial databases. Sometimes locations changes over time to time and person to person. For example, tracking a delivery vehicle, monitoring a moving cyclone, or following the animal that moves or migrates from places to places. So these applications require spatio-temporal bases, so which store both space and time information. So these databases are widely used in logistics, transportation, disaster management, and environmental monitoring. So if you take spatial databases, it's about only the spatial information, for example maps. But when you take about the spatio-temporal databases, it covers the geographical area as well as the time. For example, migration of animals from time to time, place to place. So moving on to the next slide, text databases and multimedia databases. So not all the data exists as numbers. So organizations also store huge amounts of text, images, audios, and videos. So here we have the text database. A text database stores textual information, for example the information which you have in the Word or PDF, etc., etc. So these examples includes like product description of a particular product, research papers where the scholars they write, and the emails whatever you send, then WhatsApp communication, the text which you send, then post which you post in the online social media, and also customer reviews, for example about the movies, and medical reports about the health report of the patient, etc. So all these require the textual information, depicts the textual information, and it has to be stored in text database. So it is also one another database which we require and use it then and there. Then next about a multimedia database. So from the name itself you can say and that it stores about images, videos, audio recordings, and animation. So for example the applications include like YouTube, Netflix, image search engines, and medical image systems. All these store the images and videos, so where they require multimedia databases to store about all this data. So mining multimedia data helps identify similar images, recognize speech, detect objects, and recommend videos. So this is about text and multimedia database. So next I'm going to explain about heterogeneous database and legacy database. So in many organizations, data is not stored in just one database. Large companies often use multiple database systems developed over many years. Heterogeneous database combines different databases that can communicate with each other. So I will be having different types of data that are stored in different databases. So all this could be stored in the heterogeneous, and they can have the communication with each other and passing the information. So this is what heterogeneous, different types. For example, one department may use Oracle, another one SQL Server, while another one stores their data in Excel files. So this could be taken as an example for heterogeneous database. So the next database which we are going to see, it's about older systems. So the older systems that are still being used are called as legacy databases. So even though they are old and replacing them is expensive, data mining technique help integrate information from these different sources to provide meaningful business sites. So this is about heterogeneous database and legacy database. So next it's about data streams. So we know what is data stream. For example, you take the live telecasting that could be taken as an stream data. So now let's discuss one of the fastest growing types of data. Some applications generate data continuously, as I told, for example, live feed of any information. So this is called basically data stream. Example includes stock market transaction, social media post, network traffic, weather monitoring, then IoT sensors, and surveillance cameras. So all these they generate the data continuously. So we need to analyze these data to mine the information from that. So unlike traditional databases, stream data is constantly arriving. That is an important point. It is usually impossible to store everything because it consumes more number of energy and also more storage space. Therefore, data mining algorithms process the data immediately, often in real time. Applications include fraud detection, traffic monitoring, earthquake detection, and smart cities. So next, the World Wide Web, WWW. So the largest source of data today is the internet. The World Wide Web contains billions of web pages. Data mining techniques applied to web data are known as web mining. There are several types of web mining basically. Web usage mining that studies user browsing behavior, how a person browsing, and what is a pattern that we will be able to know their usage basically. Next, web content mining, which analyzes the information available on web pages, different web pages. And third one, it's about web structure mining. So basically this studies links between web pages to determine their importance, how important it is. So search engine like Google use these techniques to rank websites and provide better search results. Companies also analyze user browsing behavior to improve websites and personalize recommendation. So let us summarize today's lecture. We learned that data mining is not limited to traditional databases. Different applications require different types of database. So today we discussed transactional, object relational, temporal, spatial, time series, multimedia, text, data streams, web databases, etc. So understanding these databases is important because the choice of mining technique depends on the type of data which you are going to analyze. So in the next lecture we will move forward and study how the data mining process extract useful information from these databases. Thank you all.